So this is sort of a classical maximization problem. Um, and I guess the first thing we need to do is to set this up. So we've got 360 feet of fence. I've already drawn the rectangular area that we're going to set in, and I labeled one side as the width, W, and the other side is the length. So when you're looking at this, and they say 360 feet of fence, they're talking about the perimeter. So the distance along all four edges here, right? That's going to take up 360 feet. So we can set up a little equation for that. We know that twice the length plus twice the width equals the perimeter. So 2L plus 2W equals 360. Okay, now we're trying to maximize the area, and we know that the area is equal to the length times the width. So our problem is we need to get the area down to a function with just one variable, not two variables. And so you're going to basically do sort of what you do for systems of equations. I'm going to solve this for, I guess I'll solve it for L. So we're going to get 2L equals 360 minus 2W, and then divide everything by 2, and you end up with L is equal to 360 divided by 2 is 180 minus 2W divided by 2 is W. Okay, so I'm going to make a substitution for this. Since L equals this, I'm going to replace L with that expression. So now we get to our function. So we're going to say that area is a function of W, right? And it's going to be 180 minus W times W. So our function, no surprise, is a quadratic function. So here's our function. A of W equals 180 W minus W squared. So we can solve this graphically pretty easily. I wish I had set that up on my calculator so I didn't have to spend time for doing that. But this is a parabola that opens down, and I'm going to rewrite it so minus W squared plus 180W. And so we know that we're going to get our maximum area at the vertex of this. So we're basically finding the vertex of this function. And since I didn't set up my calculator, I am going to use this formula. So it's the opposite of B over 2A, right? And then we're going to evaluate your function at whatever number we get for that. So the opposite of B is negative 180 all over 2 times A, and so we end up with 90. So what is that telling us? That's telling us that when the width, right, this is the W, is 90 feet, we'll get our maximum area. So maximum area width of max area is 90. You can plug that back in, and you're going to find the length is also going to be 90 feet. So this answers our question. This is the dimensions that you get, 90 by 90. So basically it's a square. You'll get your maximum area if you set up that rectangular area as a square. And if they ask for it, the maximum area for this would be, you just multiply those two together and you get 8,100 square feet. That's the maximum area that you can enclose. Alright, so that's it.